Number 11, a conical tank. The vertex down is 20 feet across the top, so that means we have a radius of 10. And 24 feet deep, which means we have a height of 24. All right, if the water is flowing into the tank, at a rate of 14 cubic feet per minute, find the rate of change and of the depth of the water when the water is 10 feet deep. All right, so we're looking for the rate of change of the depth. And I'm going to use H to represent depth because it's height. So we are looking for H prime. That's what we want when we're done. All right, but before we can do that, we need to set up some kind of relationship between some things in here. And what we know about the water in this tank is that that's volume. And we know that the volume of a cone is this right here. All right, that's got my H in it, which is fantastic because I'm looking for H prime. What I don't want in there is my R. I would like for the R to be a different letter. So I need for the R to be written in terms of H. So I need to find a relationship between R and H. Well, R is the radius as we move down, and H is the height as we move up, since the water is going in. So this is R, and this is H. So I know that there's a ratio of 10 to 24 at the top. All right, that should be proportional to anywhere else on the cone that I take the radius and the height. All right, so you could do 10 over 24 is equal to R over H, or you could do 10 over R is equal to 24 over H. Doesn't matter, it's still proportional. So when we cross multiply, and then we're going to divide, the question is, are we solving for R or are we solving for H? Well, what variable are you trying to get rid of? You're trying to get rid of R, so we're going to solve for R. All right, and then that means that R is equal to 5H over 12. So I'm now going to take this value and substitute it in for R. All right, so let's simplify this before we try to take the derivative. And then I've got 1/3. So 1/3 times 25 over 144, I'm getting 25 over 432. All right, so there's my volume with just H. Now I can find V prime so that I can find H prime. All right, 3 times that, that's going to give me 25 over 144. And then since H is dependent on time, it's multiplied by H prime. Alrighty. And then I was given V prime. I was told that the water flowing into the tank is at a rate of 14 cubic feet per minute. 14 cubic feet per minute is the rate of change of the volume. All right, now I've still got too many variables. I need to know the height. Well, at what particular time am I supposed to be finding this rate of change? I'm supposed to be finding the rate of change when the water is 10 feet deep. So I also know that H is 10 at this particular time. All right, we are ready to solve for H prime. All right, if let's see, this is 100 times that, so that's going to be 250 over 144. We're going to divide both sides. So I ended up getting and then dividing by pi at the end. So divide 14 by 25 over 144, divide 14 by 100, and then lastly divide it by pi, and this is what you should get.